So welcome back guys. In this module we will going to understand the domain name system, abbreviated as DNS. So let us go through the agenda of this module. In this module we will discuss what exactly DNS is and why do we need it. That is, we will going to discuss the problem statement. After that we will discuss the DNS architecture and design. Then we will take a look at fully qualified domain name, which is called as FQDN. Then we will discuss the first host DNS servers, and then we will discuss in detail that how exactly DNS work. So DNS works either through recursive query or through iterative query. We will going to discuss both the ways of DNS functioning. And finally, we will wind up with the discussion of reverse DNS, and then we will conclude this module with the summary. So introduction. So what exactly domain name server is? So domain name server is popularly acronymed as DNS. DNS technology facilitates the mapping of website name to IP address and IP address to website name. So let us try to understand this point. So the primary function of DNS system is to map the website name to the IP address of the machine which hosts that particular website. So this is the primary functionality of domain name system, and we do this all the time. For example, whenever you access the website, you type the name of a website in your browser. As soon as you type the name of the website in the browser and press the return key, behind the scene the domain name system maps the name of the website to the IP address of the machine which hosts that particular website. Because at the end of the day, you have to send the data packet to the server which hosts the requested website. And to send the packet to that server, you need an IP address of that server. So domain name system actually resolves the domain name of a website to an IP address of the machine which hosts that particular website. Then another function of the domain name system is to map the IP address to the website domain name. Now this function of the domain name system is exactly opposite to what we have discussed above. So given an IP address of the server machine, finding the website name which is hosted by that server machine is the function of the reverse DNS. So for example, web host server corresponds to IP address 8.8.8.8 is google.com. That is, if I give you an IP address and ask you that what is the website name corresponding to this IP address, you will say google.com. So this is the function of reverse DNS system. Whereas in the point A, if I ask you that what is the IP address of google.com, you will say the IP address of server machine which hosts google.com is 8.8.8.8. So this is the primary function of domain name system. So I hope it is clear that the function of the DNS system is to map the website domain name to an IP address, whereas the function of reverse DNS system is to map the IP address to the website domain name. So for example, as soon as you type www.google.com in your web browser, the DNS system works behind the scene and it finds out the IP address of the server machine on which the www.google.com website is hosted. So what will actually happen if we did not have DNS system? So without DNS system, you would have to type the following URL in your browser in order to reach google.com servers. And now you can think that in a given day, you browse so many websites. So remembering the IP address of all those websites is not feasible for a human being. We remember the websites by their domain names. So if you did not have DNS system in place, in order to access the website, you would have to type the IP address of the server machine on which the website is hosted, right? So instead of typing www.google.com, you would have typed http://8.8.8.8 in order to access the website www.google.com. So in this module, we shall learn the problem statement, which DNS mechanism solves, and how DNS mechanism works. DNS is actually like a phone book for the internet. DNS plays its role whenever you visit some website or sending an email. So guys, next let us discuss the problem statement of DNS systems. That is exactly what problem the DNS system helps to resolve. So whenever you type out the name of any website in your browser, you are trying to access that particular website which is hosted somewhere else on the network. So we can see in this diagram, you are trying to access the website from the machine A, and the website that you are trying to access is www.mypictures.com/index/flower.jpg, right? And let us suppose that this website is hosted on a server with IP address 13.1.1.2, and this server could be present anywhere in the world. So when you hit enter after typing this URL in your browser, your machine immediately generates a packet. Now what does that packet look like? That packet will have a data link layer header, which will be the source MAC and destination MAC, of course. The discussion of the source MAC and destination MAC is irrelevant here. Then on top of the data link layer is the IP header. In this IP header, the source IP address will be the IP address of your machine, whereas the destination IP address will be the IP address of the server on which the website is hosted. So in this case, the destination IP address will be 13.1.1.2, right? And on top of that, you will have the transport layer protocol, which could be TCP protocol. And on the top of the TCP protocol, you will have application layer protocol, which is HTML protocol. Now, since you are trying to access the flower.jpg, that is, you are trying to access the resource from the website www.mypictures.com, your HTML payload will consist of GET request and followed by the path of the resource which you want to access. So this is the packet that will be generated by the machine A. And this packet will be generated as soon as you type out this URL in your browser and press the enter key. Now two major questions arises here. What are those two major questions? How your machine knows the destination IP address of the server machine, that is, where this destination IP address came from. How your machine A came to know that 13.1.1.2 is the IP address of the server machine which hosts the website. And the second question is, the only destination identity which is provided by the user was the website name, that is www.mypictures.com. How this website name was resolved to the IP address 13.1.1.2 without you being knowing, right? All you do is to access the website by typing the website name in your browser. You never care that on which server that website is hosted, and you are able to access that website comfortably. So these questions are answered by DNS, that is domain name system. So now our problem statement is to figure out the answers of these two questions, that whenever you try to access the website, how your machine generate an IP packet, and in that IP packet, where this destination IP address came from. That is, the final problem statement is how to map the website name to the IP address of the server machine which hosts that website. So guys, now let us try to understand that what exactly DNS is. So DNS, first of all, DNS is an application layer protocol, and DNS works completely transparent to the end user. So remember, DNS is an application layer protocol. It works on the top of the transport layer protocol. So DNS is actually an application which has been designed to solve a certain problem. As an end user, you never need to learn which website is hosted on which server in the world, and it is not possible either. We always access the various websites through their names called domain names. And human can't remember the several IP address of all these websites that you access daily. So in this below diagram, you are trying to access all these websites, that is www.facebook.com, microsoft.com, udemy.com, google.com, and all these websites are always accessible to you. Did you ever configure your system to tell your system that whenever you try to access facebook.com, please go to the IP address 100.1.1.2, right? You never configured your system to do so. Similarly, did you ever configure your system that whenever you access the website www.microsoft.com, please go to the IP address 110.1.100.2, right? You never configured your system to do this. So you can see that you are actually able to access all the public websites in the world using their domain names. So again, the same question arises that how your machine is able to find the server's IP address on which website is hosted. So DNS allows you to access any public website hosted elsewhere in the world through its domain name. You don't have to configure your system to tell your system that if you want to access the website xyz.com, then go to the ABC IP address. You never configure your system to do so. You never configure your system to have this knowledge. And still you are able to access all these websites using their domain name. So this is made possible by DNS system. So DNS allows you to access any public website hosted elsewhere in the world through the website's domain name. You don't have to care that on which server machines these websites are hosted. So by now you must have understood that how DNS system is essential and very important for the internet to work. Without DNS system, you would have to maintain a diary, and inside that diary you would have to note down the mapping between the website names and their corresponding IP addresses. For example, you would have to note down in your diary that www.facebook.com is hosted on a server whose IP address is 100.1.1.2. And if you want to access this facebook.com, you would have opened your diary and checked the IP address on which www.facebook.com is hosted. And in your web browser, you would have typed out this IP address instead of facebook.com. So without DNS system, accessing the various websites with the ease which we do today would have been very difficult. Now guys, let us try to understand the DNS system architecture. DNS system is nothing but it is a group of servers called DNS servers, which works in collaboration with each other in order to implement the DNS functionality. So there are certain group of machines which works in collaboration with each other. Those machines are called DNS servers. So DNS system is nothing but it is a group of DNS servers. These DNS server machines are distributed all across the globe, and these DNS machines are distributed with sufficient redundancy. We will come back to this point later. DNS machines are monitored and managed by central authority, right? So global DNS server machines, which comes under central authority, works at two levels. The first level is a root level. DNS servers which works at root level are called root DNS servers. So you can see here it's a root DNS server. The second type of DNS servers are called top level DNS servers. These are the DNS servers which works at top level are called top level DNS servers. So you can see in this diagram that below the root DNS server comes the top level DNS servers. So you can see that there are only handful of top level DNS servers. The sum of the examples I have shown here. edu is a top level DNS server. Similarly, com, in, arpa, org and net. These are all top level DNS servers. The top level DNS servers works at one level below the root DNS server. So you can see that DNS system is actually kind of tree-like system. It's a hierarchical system. The root of this tree is the root DNS server, whereas the DNS servers which works at one level below the root DNS server are top level DNS servers. And remember, root DNS server along with top level DNS server are managed and controlled and looked after by the central authority. Now let us discuss this point, that what is meant by sufficient redundancy. Now let's come to the DNS server geographical distribution. The DNS servers, that is the root DNS server and top level DNS servers, are distributed across the globe. So redundancy means that a same DNS server has been replicated at various geographical locations around the globe. For example, in this diagram you can see that root DNS server has been replicated at these many places. It is done for the sake of fault tolerance and load balancing. That is, if root DNS server say K fails, then I will take the responsibility of root DNS server K. Whenever you access a website, the root DNS server is always used in order to map the website name with the IP address. Now, there are hundreds of millions of people who are accessing the website all around the globe. So one root DNS server cannot sustain such a great load of website requests. So it is for this reason that load balancing is required, and we need to maintain n number of root DNS servers across the globe. So here I have shown you the example of redundancy of root DNS server. Not only root DNS servers are replicated, but also top level domain name servers are also replicated in the same way. So we do the redundancy of DNS servers for two purposes, that is fault tolerance as well as load balancing. In this map, I have shown you the distribution of root DNS server all around the globe. In a similar way, the top level domain name servers are also replicated all around the globe. However, I don't think it is required to show you the geographical locations of the distribution of top level domain name servers. But top level domain name servers are also distributed and replicated in the same way as root level domain name servers are.
So guys, next we will going to discuss the hierarchical nature of a DNS system. Now DNS system by its design is highly hierarchical in nature, right? Now we know that there is one special DNS server called root DNS server. This root DNS server is at the apex of DNS hierarchical system. The other type of DNS servers are called top level domain DNS servers. Now there are about 20 to 30 top level domain DNS servers, among which I have shown you the important ones. So this edu, com, in, arpa, org, net, etc. are actually top level domain DNS servers. We can also call them as TLD servers. That is short form of top level domain DNS servers. Now, as I said, the DNS system is highly hierarchical system. That is, there has to be a parent-child relationship between these DNS servers. So that parent-child relationship is shown with the help of this dotted line, right? So you can see that in this DNS system, the root DNS server is actually at the apex of the hierarchical system, whereas these top-level domain DNS servers are at the first level of this DNS hierarchy. So top-level DNS servers are actually the children of root DNS servers. Now please note that the root DNS server together with this top level domain DNS servers comes under the control of central authority. This central authority is actually responsible for maintenance and protection of root DNS servers and top level domain DNS servers, which are distributed all across the globe. So this central authority is actually a body or a committee or you can say an organization which actually looks after the root DNS servers as well as top level domain DNS servers which are distributed all over the world. Right? Now, going to the second property of this DNS hierarchical system, that the DNS servers which are higher in the hierarchy only knows how to reach directly lower ones in the hierarchy. So you can see that in this DNS hierarchy, the root DNS server actually has a database called DNS database. In this database, the root DNS servers knows the IP address of all the top level domain DNS servers. Now top level domain DNS servers are the direct children of root DNS server. Therefore, root DNS server is supposed to know only the IP address of DNS servers which are its direct children. So you can see in this DNS database, the IP address of each of the top level domain DNS servers is stored. Similarly, the DNS servers which are one level below the root DNS servers, that is, let us say for example, COM DNS server will also have its own database called DNS database, and in its DNS database it will going to store the IP address of DNS servers which are at second level of this DNS hierarchy. So you can see that in the DNS database of COM top level domain DNS server, you have an entry for Microsoft DNS server and Google DNS server. Right? Now what does that mean? It means that Microsoft Corporation is running its own DNS server and the name of that DNS server is Microsoft DNS server. And that Microsoft DNS server is registered under COM DNS server. Right? So Microsoft must have paid to this central authority in order to have their entry of IP address in the DNS database of COM DNS server. Right? And same is true with Google DNS server. So you can see that this is a DNS server for Microsoft, this is a DNS server for Google. So each DNS server has a name. That is, Google's DNS server has a name .google, the Microsoft DNS server has a name called .microsoft, and the top level domain name servers has a name like .com, like .edu, .in, .arpa, .org, etc. Now one thing to note here is that the root DNS server along with the top level domain DNS servers are under the supervision of some central authority. But what about Microsoft and Google DNS servers? Of course, because it's a Microsoft DNS server, the Microsoft is responsible to look after their own DNS servers. Right? Similarly, Google will be responsible to look after its own Google DNS servers. The central authority has nothing to do with the management or control over the organization-specific DNS servers. So Microsoft or Google DNS servers are the DNS servers which are under the authority of their respective organization. Right? So Microsoft, that is .microsoft, is a DNS server for Microsoft. Now it is very much possible that Microsoft can maintain its another DNS server which is actually a direct children of its parent DNS server. So in this example, you can see that Microsoft has installed another DNS server called support. And because this DNS server is actually a children of another Microsoft DNS server, therefore support DNS server is called subdomain DNS server. And as I said, that coming to this point, that is, every DNS server which is higher in the hierarchy only knows how to reach the directly lower ones in the hierarchy. So you can see that in Microsoft DNS server's DNS database, there is an entry for support DNS server. Right? So Microsoft DNS servers know how to reach the support DNS server because in its DNS database, it has an IP address. And this IP address is the IP address of support DNS server. So same is true with Google. That is, Google has also launched its another subdomain DNS server called mail. So you can see that how DNS system is highly hierarchical system by design. And coming to the last point, that is the DNS servers which are at the leaf of the DNS tree, right? Those DNS servers contains the IP address of the servers which actually provides the service. So you can see in this diagram that what are the DNS servers which are at the leaves of the DNS tree. Those DNS servers are support DNS server and mail DNS server. Now, if you look at the DNS database of support DNS server, the DNS database of support DNS server stores the IP address of server whose name is customer. So within the Microsoft network, there will exist a server called customer whose IP address is 212.132.1.2. And it is this customer server which actually provides a service. Now that service could be an access to the Microsoft website. So note that customer is not a DNS server, it's a normal server which actually provides a service to the end user. Whereas all other black boxes that you can see on this slide are actually domain name servers. Also one thing to note that these dotted lines are actually not a physical links, but they are logical links. Now logical links means that, for example, the .com DNS server can reach the Microsoft DNS server or Google DNS server through L3 network. That is, the .com and Microsoft or Google DNS server could be geographically located anywhere in the world. They need not be placed together and they need not be connected via physical link. So now, having understood the hierarchical nature of this DNS system, now I ask you one question. What you have to do in order to have your own website launched publicly and you want the rest of the world to be able to access your own website through your website domain name. So let us discuss that in the next slide, that what actually you are supposed to do in order to make your website accessible through its domain name. So guys, now let us try to understand that what you are supposed to do if you want to host your own website. So let us take an example that you want to host a website www.example.com and you want the rest of the world to be able to access your website using your website domain name. That is, when any user in the world type www.example.com in their web browser, they should be able to access your website. So in order to make your website publicly accessible to the rest of the world through the website domain name, the very first thing that you need to do is to have your domain name entry registered in the top level domain name server called .com. For that, you have to request this central authority to actually insert an entry in the DNS database of .com top level domain name server. So that entry will be the name of your web server and what is the IP address that is assigned to your web server. For this entry to be made in the DNS database of .com top level domain name server, of course you have to make a payment to this central authority. They will not going to do this for free. Now once you have this entry in the DNS database of .com top level domain name server, then the rest of the world will be able to reach your web server. All you have to do is to run your web server, and your web server should be connected to the internet with the public IP address 5.5.5.8. Right? So if you do these two things, that is getting an entry in the DNS database of .com top level domain name server, and the second step is run your web server with the public IP address 5.5.5.8 and name your web server as example. If you do these two steps, then the rest of the world will be able to access your web server with the domain name of your website. So if any user in the world will type out this domain name in their web browser, the .com top level domain name server will tell that particular user that, hey, the website that you are trying to access is hosted on a server which has IP address 5.5.5.8. And the moment the user gets an IP address to your web server, the user can then directly connect to your web server and access the World Wide Web service that is provided by your server. So in this slide, I just wanted you to understand that what you are supposed to do if you want to launch your own website such that the website is publicly accessible by the rest of the world through the website's domain name. We will discuss in detail that how any random user from any part of the world with the help of this DNS system is actually able to access your website through your website domain name. Welcome back, guys. So now let us have some discussion regarding website's domain name. That is, if you want to launch your own website, then what should be the name of a website? In other words, what should be the domain name of your website? So remember, the naming of a website is just not random, but it has to be consistent with the DNS tree. So a website name and a name of the website is also called as domain name. So a website name, also called domain name, is just not any random sequence of words or strings. A website name needs to be constructed systematically, keeping DNS hierarchy in mind. Right? So a website name is constructed of individual words called literals. These literals are actually the name of DNS servers in the path of DNS tree starting from the root DNS server towards the leaf of DNS tree. Right? So for example, suppose there is a website name called customer.support.microsoft.com. So how many literals it has? It has 4 literals. That is, customer is 1 literal, support is 1 literal, Microsoft and com. So the name of this website is composed of 4 literals, right? So now let us see how website domain name is constructed or derived from DNS system with the help of an example. So remember, you just cannot choose any random sequence of words or literals as a name of your website. Right? So whatever name you choose to be the name of your website has to be consistent with the DNS tree. So now let us take an example. So you can see in this diagram, I have shown you the root DNS server and the top level DNS servers, right? And below the top level DNS server called com, there is a Microsoft DNS server. And as a child of this Microsoft DNS server, we have another subdomain DNS server called support. So this is the DNS tree, and we have been discussing about this DNS tree quite a bit now. So a website name is nothing but it is a sequence of DNS servers in the DNS tree, but in the opposite order. So let us take an example. Suppose you have a website called www.customer.support.microsoft.com. Right? Now, given this name of a website, how does the name of this website is dependent on this DNS tree? Let us try to understand that. So for a given website, always assume that there is a dot which is appended at the end of this website name. This dot actually represents the root DNS server. So as soon as you type out the name of your website in a browser, your browser automatically adds a dot in the end of your website name. So this dot represents a root DNS server. Then the first literal from the last is com. So clearly here the .com represents the top level DNS server, that is this one. Then the second literal from the last is the Microsoft. So again, .microsoft is the DNS server of Microsoft Corporation, right? And again, the third literal is the support. So support is nothing but it is a Microsoft subdomain DNS server, right? And the final literal is customer. So customer is nothing but it is the name of a server which actually provides a World Wide Web service to the end user, right? So this customer is not a DNS, but it is an actual server which provides the service. So you can see that the name of the website is actually a composition of sequence of names of DNS servers in the opposite order of DNS tree. That is, starting from the root DNS server and moving towards the leaf of the DNS server. So this is the root of the DNS server, then second is the com, then third one is the Microsoft, and the fourth one is support. And finally, fifth one is the actual web server which is providing World Wide Web service. So you can see that the name of the website is the composition of names of DNS servers starting from the root of the DNS tree and moving towards the leaf of the DNS tree. So this is how the name of the websites are derived. Right? Now let us discuss what exactly fully qualified domain name is. So for a given website name, the fully qualified domain name is nothing but it is a concatenation of the name of a server which actually provides a service. In this case, that server is customer server, right? And the second part of fully qualified domain name is the domain name which is actually the composition of DNS servers starting from the root of the DNS tree up to the leaf of the DNS tree. So the second part is actually called a domain name, whereas first part is actually called a host name. So the host name combined together with the domain name of a website is called fully qualified domain name. So what exactly fully qualified domain name represents? What is the significance? The significance is that the fully qualified domain name uniquely identifies a server which provides a World Wide Web service. For example, if I tell you that customer.support.microsoft.com, what is that? With this name, with the help of a DNS system, you can uniquely identify that this name corresponds to this server. So fully qualified domain name is actually the name of a server which actually provides a service, and given a fully qualified domain name, we can identify service providing server uniquely in the entire world. So you can say that fully qualified domain name is like a unique identity of the server which is providing a service. So remember, fully qualified domain name is the concatenation of name of a server which is providing a service. That name is called host name, and the second part of fully qualified domain name is the sequence of name of DNS servers starting from the root of the DNS tree and going or moving towards the leaf of the DNS tree, right? So fully qualified domain name is the concatenation of host name plus domain name. So thus, now concluding on fully qualified domain name is nothing but it is a unique identity of some physical server. So in this case, the fully qualified domain name customer.support.microsoft.com uniquely identify this physical server which is running somewhere in the network. So always remember that next time when you type out the website name in your browser, then think of it like you are trying to access a physical server deployed somewhere in the network. So your website name is nothing but it is a name of the physical server, and from that physical server you are actually trying to revoke the World Wide Web services. So henceforth in this module, whenever I say domain name, it means that I am trying to refer to some physical server which is running somewhere in the network. So welcome back guys. Next we will going to discuss the top level domain name servers classification. So you can see that in the DNS system we have learned that there is a root DNS server which is at the apex of the DNS tree. Then the first level domain name servers are actually called top level domain name servers. There are approximately around 1000 top level domain name servers, out of which I have shown you only 7 or 8 top level domain name servers. Now each of these top level domain name servers that you can see in the diagram are actually responsible for the websites of particular type. For example, let us take an example that you have a top level domain name server edu. So edu top level domain name server is responsible for educational websites. For example, www.mit.edu, www.stanford.edu and harvard.edu. So all educational websites such as these are recommended to be housed under edu top level domain name server. So if tomorrow you launch a certain educational website, so you are recommended to purchase the domain name under edu top level domain name server. Then the second top level domain name server, and probably the most common and the most famous one, is the com top level domain name server. The com top level domain name server is responsible for commercial organization or commercial websites. Around 90% or even more than 90% of the websites of the world are housed under com top level domain name server. So any websites which is of commercial purpose such as Microsoft.com, www.google.com, Facebook.com and many others are actually housed under com top level domain name server. So com top level domain is actually the most commonly used domain, and more than 90% of the websites are housed under this top level domain name server. Then the next top level domain name server is actually in. So in stands for India. Likewise, for other countries, there are other top level domain name servers, and as per the name of the country, the first two letters of the country represents the top level domain name server name. So in this case, this top level domain name server is a country specific top level domain server for India. And what type of websites is this top level domain name server responsible? This top level domain name server is responsible for the websites which actually show the country specific information. So in this case, the country is India. So these are the websites which actually shows the public information regarding the country India. So such websites are unacademy.in or cropin.co.in, etc. Then ARPA is actually some special top level domain, and we will take this ARPA top level domain separately in our course. So for now, just understand that ARPA top level domain name server is used for reverse DNS. Now what exactly reverse DNS is, that we will going to discuss later in this course. So we delegate the discussion on ARPA top level domain name server to be discussed later in the course. Then the next top level domain name server you can see is org. So org is responsible for all the websites which belong to non-profit organizations. For example, www.thepiratebay or wikipedia.org. So if tomorrow you launch any non-profit organization, and if tomorrow you plan to launch a website for this organization, then you will have to buy the domain name under org. And then the next top level domain name server is actually net top level domain name server, and this TLD server is responsible for the website which are actually related to internet technologies. For example, www.juniper.net is a company which work in network technology. Similarly, slideshare.net, speedtest.net, sourceforge.net. So note that it is only a recommendation that depending on the type or the nature of business you are in, you should purchase the domain name appropriately as per the business nature. So if you are launching an educational website, then you should purchase the domain name under edu top level domain. If you are launching any commercial website, then you should consider purchasing the domain name under com top level domain, right? And if you are considering to launch a website for your non-profit organization, then you should consider to purchase a domain name under org top level domain, right? So this is just a recommendation. It is not a hard and fast rule. Depending on the type of website, you should consider purchase the domain name under appropriate top level domain. So this is how top level domain name servers are classified. So welcome back guys. Now next we will going to discuss the DNS mechanism in detail. That is, we will try to understand that how actually the DNS system works. The goal of DNS mechanism is to find the answer to DNS query. That is, we need to find the IP address of the host server which hosts the requested website. So this is the entire goal of the DNS system. That is, for a given website, we need to find the IP address of the host machine on which that particular website is hosted. Now there are three ways. Now there are three different mechanisms to resolve the DNS query. The first one is the recursive method. That is, DNS query is called the DNS query. The second method is the iterative method. The DNS query is called the iterative DNS query. And the third method is the reverse lookup. DNS query. So we will discuss each of these methods of resolving a DNS query one by one. So going forward, before actually diving deep into the discussion of regarding how DNS mechanism work, we need to get familiar ourselves with some terminologies. So what is exactly DNS query delegation? We need to understand that what exactly delegation is. So let us take a real world example. For example, your friend asks you a question. The question is, so to understand the concept of this delegation, let us take a real world example. For example, you have a friend and your friend now asks you a question. Your friend asks that where is the networking class? Your friend asks you a question that when is the networking class scheduled? Your reply is that I don't know, but I think John knows. Go and ask him. Your friend says okay. So now your friend goes to John and asks. So now your friend asks the same question. When is the networking class scheduled? Now John replies, I don't know, but I think William knows it. Go and ask him. So you direct your friend to William, right? So your friend says okay and your friend goes to William and your friend asks the same question. Now this time your friend is asking William, when is the networking class scheduled? Now William knows the answer and he simply says 9 a.m. Now your friend says thanks and he got the answer for which he was looking for. Now in this discussion, you can see that there are two query. Now in this discussion, you can see that query delegation has been done 2 times. The first one was done by you and the second one was done by the John. The first one was done by you. The first one was done by you. The first one was done by you and the second one was done by John. So query delegation means in the event when you did not know the answer, you actually responded to your friend with the referral answer. So referral answer means that I do not know the answer. Please refer to somebody else to get your query answered. Similarly, John also replied to your friend with a referral answer. Whereas when your friend asked the same question to William, William replied with a definite answer. So there are 2 types of answer, the referral answer and the definite answer. Definite answer is the answer which actually answers your query, whereas referral answer is an answer which do not give exact answer to your query, but it helps to find your answer. But it points to a resource which could actually help to find the answer to your query. So I hope with this very simple example, I am able to explain the concept of query delegation and what is referral answer and definite answer. These terms will going to be used when we will be discussing the DNS mechanism. Now let us try to understand the same concept of query delegation but in terms of DNS systems. A DNS server delegates all DNS queries for its subdomain to its child DNS server. So you can see in this example that when .com DNS server receives the DNS query, the .com DNS server simply delegates this query to its child DNS servers. So in this example, we assume that the DNS query is coming for the domain name Microsoft.com and Google.com, right? So in this example, .Microsoft and .Google are the child DNS servers of .com DNS servers. So when .com DNS servers receives the query, .com DNS server receives the DNS query that hey, what is the IP address of www.x.y.microsoft.com. The .com DNS server finds out that this query need to be resolved by the Microsoft DNS server. So simply the .com DNS server delegates the query to the Microsoft DNS server, which is its child DNS server, which is the child DNS server of .com DNS server. Similarly, when .com DNS server receives the DNS query that hey, what is the IP address of www.a.b.google.com, the .com DNS server will find that it has a the .com DNS server knows that it has an entry in its DNS database for Google DNS server. So it simply delegates this query. So it simply delegates the query for www.a.b.google.com to its Google DNS server, to the Google DNS server. So you can see in this example that every time the .com DNS server receives the DNS query, and if that DNS query is related to the subdomain of .com DNS server. And if that DNS query is for subdomain which comes under the .com DNS server, then .com DNS server simply delegates those DNS query. Then .com DNS server simply delegates this DNS query to its child DNS servers. So in this example, we say that .com DNS server is an authoritative DNS server for .google.com and .microsoft.com domains and subdomains. Right? So this .com DNS server is an authoritative DNS server for all the domains and subdomains which comes under this .com DNS server. For example, .microsoft.com is a domain and this domain comes under the .com DNS server. So therefore, .com DNS server is an authoritative DNS server for .microsoft.com domain. So here authoritative means that any DNS query .com DNS server is responsible for resolving the DNS query which comes for the domain names .google.com and .microsoft.com and for .microsoft.com. So in this slide we learned the concept of query delegation as well as what are authoritative DNS servers. So welcome back guys. Now next we will going to discuss the DNS mechanism in detail. That is, we will try to understand that how actually the DNS system works. The goal of DNS mechanism is to find the answer to DNS query. That is, we need to find the IP address of the host server which hosts the requested website. So this is the entire goal of the DNS system. That is, for a given website, we need to find the IP address of the host machine on which that particular website is hosted. Now there are three different mechanisms to resolve the DNS query. The first one is the recursive method. That is, DNS query is called the DNS query. The second method is the iterative method. The DNS query is called the iterative DNS query. And the third method is the reverse lookup DNS query. So we will discuss each of these methods of resolving a DNS query one by one. So guys, welcome back. In this slide we will going to understand what is first hop DNS servers. So we will discuss what are first hop DNS server machines, what is the purpose and role of these first hop DNS server machines in the internet technology, and what problem do these first hop DNS server machines solve. So you can see in this diagram, the first hop DNS server is just a server which is present elsewhere in the network. And of course, it is you which is sitting behind your ISP and you are connected to the internet through your internet service provider. So this is the very basic topology that we will going to use in order to understand the functionality of first hop DNS servers. So going forward guys, our computer is assigned the address of first hop DNS server, And this address is assigned either statically or manually. That is, the administrator himself configures your machine with the IP address of first hop DNS server, right? So this is one way your machine could be configured with the IP address of first hop DNS server. If not manually, then there is a special protocol called DHCP protocol. Using this protocol, your machine can automatically obtain the IP address of first hop DNS server from your internet service provider. So in either ways, the end result is that your machine is aware of the IP address of first hop DNS server. So you can see, if you go to the TCP IP properties on your Windows operating system, you can see that your operating system gives you the facility to manually configure the IP address of first hop DNS server. So you can see in this column that you can specify the IP address of first hop DNS server on your local machine. So if you don't want to use any dynamic protocol such as DHCP, you can always hard code the IP address of first hop DNS server on your local machine. Now let us discuss that what is the functionality of first hop DNS server. Our computer always first asks the first hop DNS server to obtain the IP address of the domain name of a website we are trying to access. So when you try to access any website on the internet, the first thing that your computer needs is to obtain the IP address of the host server machine which is hosting that particular website. And to know the IP address of that particular host server, your computer first asks the first hop DNS server that, hey, what is the IP address of a website which I am trying to access? Now there are two possibilities. The first hop DNS server will either have a website address or it will not have. So if first hop DNS server has the IP address of the host server machine which hosts the requested website, it returns the IP address to our computer, right? Else, that is, if our first hop DNS server do not have the IP address of the host server which hosts the requested website, then the first hop DNS server queries the root DNS server on our behalf to obtain the IP address of the requested website. So we will going to discuss this functionality of first hop DNS server more elaboratively in the next slide. First hop DNS server are also called DNS resolver. And what is the reason? The reason is that first hop DNS server takes the responsibility to query the entire DNS system to obtain the IP address of the website you are trying to access. Right? So first hop DNS server is an interface between you and the rest of the DNS system. And it is the first hop DNS server that will bring an IP address for the website you are trying to access from the DNS system. So another property of first hop DNS server is that first hop DNS server caches the recently accessed website's IP address in its local DNS cache. So you can see that this represents a local DNS cache, right? So first hop DNS server caches the recently accessed website's IP address in their local DNS cache, so that in future our computer can obtain the IP address of recently accessed website quickly from the first hop DNS server. Right? In that case, the first hop DNS server would not have to query the DNS system in order to obtain the IP address of the requested website, because that particular website is recently accessed website, and the first hop DNS server would store the IP address of recently accessed website in its local DNS cache. And remember, first hop DNS server is shared by several users. It's not like that there is one dedicated first hop DNS server for you. The first hop DNS server is shared among many users. And like first hop DNS server has a local cache, our computer also have its own local DNS cache. So the purpose of this local DNS cache is same, that is, recently accessed website's IP address will be going to store in your computer's local memory. so that in future if you try to access the same website again, your computer would know the IP address of such website, and it really do not depend on the external DNS system to obtain the IP address for recently accessed websites. So this is done to speed up the access to the recently accessed website. Now next, let us try to understand the functionality of First Hop DNS server in little more detail. So let's say on your computer you are trying to access the website www.customer.support.microsoft.com, right? So for example, you are trying to access this website. So what your computer will do? Your computer will look up in its local DNS cache. So let us assume that you are accessing this website for the first time. Therefore, your local DNS cache will not have the IP address for the host server which actually hosts this website. So in this case, your computer will send the DNS query to the First Hop DNS server. And what is the meaning of this query? This query means that what is the IP address of www.customer.support.microsoft.com, right? So DNS query is a DNS message that your computer or local machine will send to the First Hop DNS server. And how your machine is able to send this DNS query to the First Hop DNS server? Because we discussed in the beginning that your machine knows the IP address of First Hop DNS servers. Now First Hop DNS server will receive this DNS query. After receiving this First Hop DNS query, the First Hop DNS server will check in its DNS cache whether it has an IP address for the requested website, right? So let us assume that this First Hop DNS server knows the IP address of this website. Then in that case, this First Hop DNS server will going to reply back to our computer with a DNS reply. And what is DNS reply? So DNS reply is another DNS message, and DNS reply means that IP address of website www.customer.support.microsoft.com is 8888. So simple. So you can see that if First Hop DNS server has an IP address of the requested website in its local cache, then it reply back with the DNS reply conveying our machine with the IP address of the requested website. But now what if First Hop DNS server also do not have IP address of the requested website www.customer.support.microsoft.com? What will happen? So let us try to understand this scenario next. So guys, let us try to understand the configuration that we need to do on a First Hop DNS server. So First Hop DNS servers are configured such that they know the IP address of root DNS servers. So you can see that we have a First Hop DNS server, and the DNS database of this First Hop DNS server is populated with the IP address of root DNS servers. So somewhere in the network we have root DNS server whose IP address is 1.1.1.1. So in the DNS database we have an entry for this root DNS server. Similarly, the IP address 1.1.1.2 will be the IP address of some other root DNS server. So remember, root DNS servers are replicated all across the globe. So this is the basic configuration that we need to do on First Hop DNS server. Now, if First Hop DNS servers do not have the required information, so remember you were trying to access the website www.customer.support.microsoft.com and your computer had sent the DNS query to the First Hop DNS server asking the IP address of this website. So now let us suppose that First Hop DNS server do not know the IP address of this requested website. So in that case, the First Hop DNS server simply propagate your DNS query to the root DNS server. Because the First Hop DNS server knows the IP address of root DNS servers, it can very well send any message to the root DNS server. So in this case, in the event when first hop DNS server do not know the IP address of the requested website, the first hop DNS server delegate the responsibility to know the IP address of the requested website to the root DNS server. And it does this by propagating the DNS query to the root DNS server. Right? Now what happens thereafter? So in that case, we will try to understand the complete DNS mechanism to resolve the website domain name to IP address. So by now you know the functionality of first hop DNS servers, that is why it is there. And now from here we can now dive into a complete discussion of DNS mechanism. That is how DNS system is able to resolve the website domain name to an IP address. So next we will going to discuss that how actually DNS system works. So welcome back guys. So next we will going to discuss the complete DNS mechanism in detail. We will learn that how a given fully qualified domain name can be mapped to an IP address using DNS system. For example, you have a fully qualified domain name of some physical server which is customer.support.microsoft.com. Now given this fully qualified domain name, how DNS system will help you to find the IP address of this physical server which is operational somewhere in the network. So DNS mechanism is all about mapping the fully qualified domain name to its IP address. So going forward, the first method of resolving fully qualified domain name to IP address is using recursive DNS query. Right? After that we will going to discuss iterative DNS query. So in this lecture video we will going to discuss the concept of recursive DNS query. Recursive DNS query is one way using which the fully qualified domain name is resolved to an IP address. So we will going to discuss how recursive DNS query works step by step. So let us start that you have a host computer and you are connected to the internet using your local machine. Right? And now you want to access a website www.customer.support.microsoft.com. So in order to access this website, you type out this website name in your browser and press the enter key. So the moment you press the enter key, what happens next? Your local system, that is your computer, looks up in the local cache to find the IP address of domain name customer.support.microsoft.com. So let us assume that you are accessing this website for the first time. Therefore, in your local DNS cache, the IP address of this domain name will not be present. Right? And be reminded that this is actually fully qualified domain name. So the next thing that your local system does when it do not find the IP address for this fully qualified domain name in its local DNS cache is that your local computer system sends out recursive DNS query to the first hop DNS server, which is also called as DNS resolver. So you can see here in the step 1, your computer system sends out recursive DNS query to the DNS resolver. So DNS resolver is nothing but it is a first hop DNS server which is configured in your local machine. So what is actually the content of this DNS query? Here DNS query means that what is the IP address of fully qualified domain name customer.support.microsoft.com. So this is actually a fully qualified domain name. You can assume that there is a dot in the end of this fully qualified domain name, which represent actually a root server. So this DNS query is all about finding the IP address of a physical server whose fully qualified domain name is customer.support.microsoft.com. So going forward, once the DNS resolver receives this DNS query, what is the next step? The first hop DNS server, that is your DNS resolver, looks up in its local DNS cache to find the IP address of domain name customer.support.microsoft.com. right? So we assume that it is for the first time that DNS resolver has received the DNS query for this fully qualified domain name. It means that in its DNS cache, it will not find the IP address of this fully qualified domain name. So in such a situation, DNS resolver will send out this recursive DNS query to the root DNS server. So remember, our DNS resolver are always configured with the IP address of root DNS servers. So in this situation, when DNS resolver itself do not know the IP address of the fully qualified domain name specified in the DNS query, the next step that the DNS resolver do is to forward this recursive DNS query to the root DNS server. So this is the step 2. Now once the root DNS server receives this DNS query, what does it do? The root DNS server are iterative servers. First of all, the root DNS servers are iterative DNS server, meaning they always reply back with the referral answer to this DNS query which they receive. Right? So root DNS server having received this DNS query, root DNS server do not query any other DNS server to get the definite answer. Why they do not query? Because root DNS servers are always iterative server. All they do is to reply with the referral DNS answer. So root DNS server checks that the DNS query is for .com domain. That is, the last literal in this DNS query is for .com domain. It means that the root DNS server will figure out that this query should be resolved by .com top level domain name server. So root DNS server replies with the IP address of .com top level domain server to the DNS resolver. So you can see in step 3, the root DNS server is replying the DNS resolver with the referral answer. In this referral answer, the root DNS server simply says that I do not know the IP address of fully qualified domain name which you are asking, but .com top level domain server potentially know the answer. Right? So root DNS server replies back with the referral answer, and in this referral answer it specifies the IP address of next domain name server. In this case, the next domain name server is the .com top level domain name server. So when the DNS resolver or first hop DNS server receives this referral answer from the root DNS server, the first hop DNS server retrieves the IP address of next DNS server. In this case, this next DNS server is .com top level domain name server. Right? So now DNS resolver knows that the next DNS server should be .com top level domain name server, and therefore it sends out the same DNS query to .com top level domain name server. So in step 4, you can see that the DNS resolver has sent out the DNS query to the .com top level domain name server. Now same thing happens on .com top level domain name server. It actually do not know the IP address which corresponds to fully qualified domain name customer.support.microsoft.com. Right? You can see in the DNS database of .com top level domain name server, there is no such entry. But .com top level domain name server knows that the next domain which is a part of this FQDN is Microsoft. So .com top level domain name server knows that the potential answer of this DNS query could be answered by the next DNS server, which is .microsoft DNS server. So you can see in the step 5, .com DNS server do not have the IP address of requested FQDN in its DNS database. So it responds with the referral answer as DNS reply to DNS resolver. Right? And in this DNS reply, it specifies the IP address of next DNS server, which is .microsoft.com.dns server, that is this DNS server. So now, as a next step, the DNS resolver again retrieves the IP address of next DNS server from referral response. Note that this referral response is received from .com top level domain name server. Now DNS resolver sends out DNS query to the next DNS server, which is .microsoft.com DNS server. Again, the same thing happens. The .microsoft.com DNS server replies back with the referral answer to DNS resolver and asking the DNS resolver to contact the next DNS server, which is .support.microsoft.com DNS server. Right? So you can see that .microsoft DNS server again replies back to the DNS resolver with the referral answer. So again the same cycle is repeated. The DNS resolver then again sends out the query to the next DNS server. Now at this time the next DNS server is .support.microsoft.com. So you can see in the step 8, the DNS resolver has sent out the same DNS query to the support DNS server. Now here something different happens. The .support.microsoft.com DNS server has the IP address of FQDN in its DNS database. So you can see that it has the IP address of FQDN. So this entry, you should read this entry as customer.support.microsoft.com. Right? So in the DNS database of support DNS server, it has the IP address of the requested fully qualified domain name. So as a result, the support DNS server replies back with the definite response to the DNS resolver. So note that in step number 9, the support DNS server is replying back with the definite response. Definite response means that it is actually telling the DNS resolver that the actual IP address of the fully qualified domain name is 212.132.1.2. As a result, the DNS resolver has now received the answer it was looking for. So when the DNS resolver has received the definite answer from the support DNS server, it makes an entry in its DNS local cache. And what entry it makes? It makes this following entry. That is, for this particular fully qualified domain name, the IP address is 212.132.1.2. Right? So DNS resolver now has received the DNS resolution for the requested DNS query, and now DNS resolver as a next step forward the DNS reply to your local machine, which in turn makes the same entry in its local DNS cache for future request. So we can see that the DNS resolver in step 10 has made an entry of this fully qualified domain name to IP address mapping in its local DNS cache. And when it sends DNS reply to your local machine in step number 12 also make a similar entry in its local DNS cache. So this is a complete mechanism regarding how recursive DNS query is resolved by the DNS system. If you analyze this in a little detail, you will realize that the DNS resolver actually takes the responsibility to get the final definite answer to the DNS query it is trying to resolve. The DNS resolver keeps on sending the DNS query to the subsequent DNS server again and again until it receives the final definite answer to its DNS query. And once it receives the definite answer, it takes care to forward the DNS reply to the DNS client, which is actually your system. So you can see that in this recursive DNS query approach, the DNS resolver is actually burdened with the responsibility to get the DNS resolution for the requested fully qualified domain name. And once it gets the DNS resolution means the IP address of the fully qualified domain name, it forwards that DNS resolution to the DNS client. And what is this DNS client? The DNS client is nothing but it is your local machine. So this is DNS client. So this is how recursive DNS query works. So let us discuss the main points regarding recursive DNS query. It is the responsibility of DNS resolver DNS server to yield a definite response to the requested DNS query. Right? DNS resolver keeps on sending the DNS query to the subsequent DNS server in an attempt to obtain definite response to the DNS query. Now what is this definite response? This definite response is either the IP address of the fully qualified domain name which is requested by the DNS client, or it is an error message. Error message means that it could not find the IP address of the requested fully qualified domain name. So this definite response is either the IP address or an error message. DNS resolver replies the host machine, that is the DNS client, which is actually the original originator of the DNS query. It replies either with a definite response or an error message. Root and top level domain name server replies with the referral answer to the DNS resolver. DNS resolver makes an entry in its local DNS cache when it receives the definite DNS resolution for a DNS query to entertain future DNS query request. Right? So if DNS client again issue a request for the same fully qualified domain name, and when the DNS query for that request is received by the DNS resolver will look up in its local DNS cache and will find that there is an IP address already in its local DNS cache for that particular fully qualified domain name. So instead of sending out DNS query to the rest of the DNS system, your DNS resolver itself will reply back to the DNS client with the definite answer. Your host machine, that is the DNS client machine, also caches the DNS resolution to entertain future DNS query request, right? So if you try to access the same website again, your computer will not send out DNS query out to the DNS resolver because it will have the IP address of recently resolved DNS query in its local DNS cache. So guys, next we will going to discuss iterative DNS query. So iterative DNS query is an alternate mechanism to resolve the fully qualified domain name to its IP address. So in this DNS mechanism, the host machine means the DNS client, that is your computer. So that host machine generates the iterative DNS query. In the previous example, the host machine generated the recursive DNS query. In this scenario, your host machine is configured such that it generates only the iterative DNS query to obtain the IP address of some fully qualified domain name. DNS query packet format has a flag which states whether it is a recursive DNS query or it is a iterative DNS query. In this mode means in iterative DNS query mode, the DNS resolver do not take the responsibility to recursively ask other DNS server in a hope for a definite response. If DNS resolver itself do not know the DNS resolution for requested fully qualified domain name, it too returns with the referral response to the DNS client host machine. Right? So we will going to discuss all these steps more elaboratively with the help of an animated diagram on the next slide. The DNS client machine, having received the referral response either from the DNS resolver or other DNS server, sends out the DNS query to the next DNS server specified in the last referral response. Right? So DNS client machine itself takes up the role which DNS resolver was doing in case of recursive DNS query. So we will going to understand all these points more elaboratively and in detail with the help of an animation. I am just giving you the overview regarding how iterative DNS query works. And then rest of the mechanism is same as that of recursive DNS query. So let's see how iterative DNS query works. So you can see in this diagram you have a DNS client, and this DNS client is nothing but your system, but your local system. And your local system is configured with the IP address of first hop DNS server, which is also called as DNS resolver. So whenever you access the website www.customer.support.microsoft.com, your local machine generates a DNS query and sends out this DNS query to the first hop DNS server. Now this DNS query is all about asking that what is the IP address of fully qualified domain name customer.support.microsoft.com. So remember, in this example, your computer machine is configured to generate an iterative DNS query. So this DNS query is iterative in nature. So as a first step, the DNS client generates the DNS query and sends it to the DNS resolver. If DNS resolver do not know the IP address of requested FQDN which is specified in the DNS query, the DNS resolver replies with the referral answer to the DNS client, suggesting to send the DNS query to the root DNS server instead. So you can see in this case, your DNS resolver itself replies back with the referral answer to the DNS client. And using this referral answer, your first hop DNS server is actually saying that I do not know the DNS resolution of the requested fully qualified domain name. Please go and ask the root DNS server whose IP address is the following, that is IPX. So let's say the IP address of the next root DNS server is IPX. So you can see that in this example, the first hop DNS server is not taking the responsibility like it did take in the case of recursive DNS query to go and ask each of the DNS server in the DNS system in a hope for the final DNS resolution of the DNS query. But instead, in this example, the first hop DNS server is actually replying back with the referral answer to your local host machine. So it is the responsibility of your local host machine to find the DNS resolution by sending the DNS query to the DNS server, which is specified in the referral answer it has received. So in the step 3, you can see that your host machine is sending out the DNS query to the root DNS server. So root DNS server replies with the referral answer to the DNS client, suggesting to ask the next DNS server, which is .com top level domain name server. So you can see that the root DNS server is now replying with the referral answer to your local host machine. So this is what is the difference between iterative DNS query and recursive DNS query. The rest of the procedure to obtain the final DNS resolution for this DNS query is exactly same as that of the recursive DNS query. So rest of the steps are exactly same as recursive DNS query. That is, your host machine will now send the DNS query to the .com top level domain name server. And top level .com domain name server will again reply back with the referral answer to your local host machine, and in that referral answer it will specify the IP address of the next domain name server, and that domain name server will be Microsoft DNS. So DNS client keeps on sending the DNS query to next DNS server as per the referral answer received until it receives the definite response from .support.microsoft.com DNS server, right? So DNS client, having received the final DNS resolution, will cache the DNS resolution in its local DNS cache for future requests. So you can see in this example, the DNS server, which in its DNS database actually had the IP address corresponding to the requested fully qualified domain name, will reply back with the DNS reply. And in this DNS reply, it will specify the IP address of the requested fully qualified domain name. So this definite answer will be received by the host machine, right? And as I've discussed, the host machine will going to save this DNS resolution in its local DNS cache in order to resolve future similar DNS requests without going through all this cycle again. So let us discuss the difference between iterative DNS query and recursive DNS query. So the first point says that in case of recursive DNS query, the DNS resolver takes the responsibility to get the final DNS resolution. Whereas in case of iterative DNS query, the DNS client has to work itself to get the DNS resolution. Point number 2 says that the DNS resolver keeps sending the DNS query to subsequent DNS server based on referral answers. Whereas in case of iterative DNS query, it is the DNS client which keeps on sending the DNS query to subsequent DNS server based on the referral answers. Then point number 3 says that the DNS client receives a definite answer. So that definite answer is either the DNS resolution of the requested fully qualified domain name, or it is an error message. In either of these cases, both these messages are classified as definite answer. But in case of iterative DNS query, the DNS client receives either a referral answer or an error message. And finally, in step 4, you can see that the burden was on DNS resolver. That is, it was DNS resolver which came forward and took the responsibility to actually find the final DNS resolution by querying the DNS system again and again. Whereas in case of iterative DNS query, the burden was completely on DNS client. That is, your local host machine was responsible to send out the DNS query again and again to the subsequent DNS server in a hope to find the DNS resolution for the requested fully qualified domain name. So this is all about iterative DNS query and recursive DNS query. So let's now discuss that once the DNS client receives the IP address of the requested fully qualified domain name, what is the next step that is done by the DNS client? So guys, going forward, so what is the next step to be done after the DNS resolution has been done? So remember, whether your laptop or your machine has generated either iterative DNS query or recursive DNS query, the end result will going to be that you will know the IP address of the host server which actually hosts the requested website. So here we assume that your machine has obtained the IP address of the requested website. Now once you know the IP address of the host server, so in this example the host server is this machine, which is actually in operation in Microsoft network. So now because you know the IP address of this host machine directly, you can communicate with this machine directly over the internet, and whatever data exchange you need to do, you can then carry out. So in this example, your machine wanted to access this website, and now this website is hosted on this customer machine. So your machine can directly access this website which is hosted on this machine. Right? So as soon as you know the IP address of any machine in the internet, you can always set up the communication with that machine in whatever way you want. So when your machine is carrying out communication with this customer machine, the IP packet that is generated by your machine will have the destination IP address in the IP header equal to the IP address of this customer machine, which is 212.132.1.2. Right? So once your machine knows the IP address of the customer machine, then at this point of time, the job of DNS system or DNS mechanism is over. So guys, next we will going to discuss the reverse DNS mechanism. So what exactly reverse DNS is? The reverse DNS is all about that for a given IP address, find the fully qualified domain name. For example, you are given an IP address 212.132.1.2. Now given this IP address, the reverse DNS help us to find the fully qualified domain name which corresponds to this IP address. Right? So previously, given a fully qualified domain name, we were trying to find the IP address of the physical machine which has that fully qualified domain name as its name. But in this example, given an IP address, we need to find a physical machine which has the fully qualified domain name which maps to this given IP address. So here you can see in this diagram, there is a special top level domain name server called ARPA server. This ARPA server is special in the sense that this top level domain name server is dedicated to handle reverse DNS queries. Right? So this is ARPA DNS server which will going to handle all the reverse DNS queries. Now you can see in the DNS database of this ARPA DNS server, there are two entries. So these two entries corresponds to the IP address of child DNS servers. So there are two child DNS server of ARPA DNS server. The first child DNS server is in -addr DNS server, and the second child DNS server is IP6 DNS server. So when the reverse DNS query comes for IPv4 address, the ARPA DNS server delegates the reverse DNS query to in-addr DNS server, and if reverse DNS query comes for IPv6 address, then ARPA DNS server delegates the query to IP6 DNS server. So ARPA is a special top level domain name servers which is actually responsible to find reverse DNS resolutions. You can see that in the reverse DNS database of root DNS server, there is an entry for .arpa DNS server. So here the goal is that for a given IP address we need to find the fully qualified domain name. That is, we need to find the machine whose fully qualified domain name maps to this IP address. So now we will going to discuss the mechanism regarding how reverse DNS query are actually resolved by the DNS system. So the procedure is exactly same as iterative or recursive DNS query processing by the DNS system. So you can see that you have a DNS client here, which is your local machine, and your local machine is configured with the IP address of your first hop DNS server, which is also called as DNS resolver. So your local machine generates the reverse DNS query, right? So what is the meaning of this reverse DNS query? This reverse DNS query means that what is the fully qualified domain name for IP address 212.132.1.2. Right? So your DNS client machine is expecting the answer from the DNS system that the fully qualified domain name for this IP address is customer.support.microsoft.com. So let's see how DNS system actually handles the reverse DNS query and finds the fully qualified domain name for a given IP address. So as a first step, when your DNS client issue a reverse DNS query for IP address 212.132.1.2, your system do the following before actually issuing a reverse DNS query. The first step is that your system actually reverses the IP address, right? So you can see that the octets of the IP address are reversed. In the second step, your local system actually appends the partial domain name in-addr.arpa. So the final reverse DNS query will be what is the domain name of the following modified IP address. So you can see that the IP address has been reversed, and not only that, it has been appended by the in-addr.arpa.string, which is actually a path in the DNS tree. So whenever I say reverse DNS query, it would mean that what is the domain name of this following type of string. Now let us try to understand the complete mechanism regarding how reverse DNS query is resolved. So here the given is the IP address, and to determine is the fully qualified domain name for this IP address. So as I have discussed in the previous slide, the DNS client will modify the IP address, and it will modify the IP address as shown below. So the reverse DNS query is exactly that what is the domain name of 1.2.132.212.in-addr.arpa. So this is the actual reverse DNS query which will be issued by your DNS client. Now note that when the DNS client issues this reverse DNS query could be iterative DNS query or it could be recursive DNS query. So depending on the type of reverse DNS query issued, the first hop DNS server will going to handle this reverse DNS query accordingly. So let's assume that in this example, this reverse DNS query is actually an iterative DNS query. So if it is an iterative reverse DNS query, your first hop DNS server will going to reply back to the DNS client with the referral response. And in that referral response, the first hop DNS server will specify the IP address of the root DNS server, which the DNS client should forward its reverse DNS query. So as a result, your client machine will send out reverse DNS query to the root DNS server. And as usual, the root DNS server will reply back to the DNS client with the referral response that the next top level domain name server that your local machine should send the DNS query to should be .arpa DNS server. So it is replying with the IP address of .arpa DNS server. So in this step, your client machine has now received the recommendation from the root DNS server that the next DNS server your client machine should contact should be .arpa DNS server. So your client machine will next send the DNS query to this .arpa DNS server, and as a result, the .arpa DNS server will again reply back to your client machine with the referral response, and in this referral response, the .arpa DNS server will recommend to contact the next DNS server, which is actually in-addr DNS server. So let's straight away jump to the step when the in-addr DNS server has actually received the reverse DNS query from the client machine. So now going forward from this point, these DNS server, that is in-addr DNS server or IP6 DNS server, actually has a prefix tree. So prefix tree is actually a mapping between an IP address and domain names. So the enlarged view of this prefix tree I have shown here. So you can see that in-addr DNS server maintains a complete prefix tree. In this prefix tree, any given IP address could be looked up. So when this in-addr DNS server receives this reverse DNS query, it parses the IP address that is specified in reverse DNS query exactly in the opposite order. So the first octet of the IP address is 212. After that it will parse 132. After that it will parse 2 and then followed by 1. So in this opposite sequence, the in-addr DNS server will going to look up in this prefix tree. So the first octet of the IP address is 212, the next is 132, the next is 2, and the next is 1, right? So at the root of this prefix tree, there is a mapping between an IP address and the domain name. So you can see that if you look up the IP address 212.132.2.1 in this prefix tree, finally this IP address will going to map to the entry customer.support.microsoft.com. So this is the fully qualified domain name, which is actually the final resolution of the reverse DNS query. So as a result, this DNS server, that is in-addr DNS server, will reply back with the RDNS reply to the first hop DNS server. The first hop DNS server will going to cache this reply in its local DNS cache, and after that it forwards this RDNS reply to your local machine. So what exactly RDNS reply is? The RDNS reply is that customer.support.microsoft.com is the domain name of 1.2.132.212.in-addr.arpa. So basically your local host machine has now received the fully qualified domain name for the IP address 212.132.1.2. And finally your local host machine will going to cache this DNS resolution in its local DNS cache to entertain future requests quickly. So the two DNS server, that is in-addr DNS server and IP6 DNS server, are special in the sense that they maintain a prefix tree, and prefix tree is nothing but it is a mapping between an IP address and domain names. For any given IP address, you just reverse the octet of the IP address and perform the lookup of this IP address in this prefix tree, right? And when you perform the lookup of any IP address in this prefix tree, you will always end up with the fully qualified domain name corresponding to the IP address. So it is this fully qualified domain name which this in-addr DNS server replies with the RDNS reply. So let us discuss the highlighted points for reverse DNS query. Reverse DNS lookup is exactly opposite of normal DNS lookup. Reverse DNS lookup query can be both iterative or recursive. ARPA is a top-level domain name server responsible for handling all recursive DNS queries. In-addr for IPv4 address is the second-level domain name server responsible to provide definite response to our DNS query. IP6 DNS server is IPv6 counterpart of in-addr DNS server. Reverse DNS is used in troubleshooting or in commands like traceroute commands and etc. So guys, let us summarize what we have learned in this module. So DNS system is hierarchical and decentralized. The root DNS server and top level DNS server are under central authority, and that authority is called INA. Second level and below DNS servers are under the authority of their respective organization. First hop DNS server is also called DNS resolver. DNS resolver and your own system caches the recent DNS resolutions to speed up the future DNS requests. Recursive DNS query is returned with the definite response. So here it means that it is the first hop DNS server which has the responsibility to return the response to the recursive query with the definite response. Iterative DNS query is returned by the referral response by the first hop DNS server. DNS servers are replicated at multiple geographical locations. And what is the reason behind it? The reason behind it is high availability, redundancy, and fault tolerance, and also load balancing. ARPA top level domain DNS server is responsible for IP to domain name resolution. Domain name system is like an internet phone book. So this example actually summarizes the DNS system in its totality, that domain name system is like an internet phone book.